Alright, so let's learn how to sketch graph a polynomial function. There's a few hints that may help you out here. Number one is you're going to want to apply the leading coefficient test. That'll tell you kind of like the end behaviors of your graph, whether it's an odd function, even function, and how your graph is going to end up. You want to find the real zeros, and then you can plot a few extra points and then draw your graph. So if we want to talk about our leading coefficient test, then we need to look at our end behaviors. So we're going to try to figure out what is your f of x doing as your x approaches negative infinity, and what is your f of x doing as your x approaches positive infinity. So if we look at our degree, we have a degree of 3, which means your graph is going to be going like this or like this. And so if you look at your leading coefficient as a positive, that means we're going to have a graph like this. So on the left-hand side, your graph is going to be approaching negative infinity. And on the right-hand side, your graph is going to be approaching positive infinity. So that means you're going to have something here, something going up like that. So now the next thing we want to do is we want to find some zeros. Drop the zero, give it the hero. That's my motto. Alright, so if we take 2x cubed minus 6x squared, and if we set this equal to 0, we should be able to factor something out of here. So say, take out 2x squared. That leaves us with x minus 3. So that if we say we have 2x squared equals 0, x minus 3 equals 0. Here you're going to get x squared equals 0, or x equals 0. Now you do have a multiplicity of 2 here. So remember, if you have an even number of multiplicities, that means at 0, at your point here at 0, your graph is going to be touching it. Or your graph is going to be going down to 0 and coming back up, or it's going to be going up to 0 and coming back down. It doesn't go through it. Now here you're going to have a 0 at, at x equals 3. And so that means over at 3, your graph is actually going to be intersecting your x-axis. So the last thing we should do is we should find some points that are on your graph. So here's an x and a y. We already have a 0, we don't have a 1, 2, we have a 3, we don't have a 4. So let's plug in some other numbers. Let's say negative 2, negative 1. 0 we already know is 0. If you plug in a 1, 2, 3, 4, 5, or 1, 2, 3, we'll say 4, then you know that at 3 you have a 0. Well, if you plug in these other points, just for time's sake, if you plug in negative 2, you're going to get a negative 40. If you plug in a negative 1, you're going to get negative 8. 0, 0. Plug in a 1, you get negative 4. Plug in 2, you get negative 8. Plug in a 4, you get a 32. So if you go back to down 40, all the way down there, off the screen. If you go back 1, down 8, that's going to be somewhere around in here. And then that means, that means your graph is going to be coming up through, it's going to touch 0. Remember, 0 has a multiplicity of 2, so it's going to be touching 0 and turning back down. So if we have a 1 over 1 negative 4, over 2 down 8, once again, this is around here. And then a 3, 0, so this is going to go down through 1, 4, go down to 2, negative 8, and then go back up through here. Here is your graph. So that is how you can use your leading coefficient test, finding some of your zeros to help you out, and then plotting some extra points to graph your function.